Alright, welcome back, hobby welders. So we're going to start a little fabrication series. I'm going to show you how to, if you just got a new welder, you're trying to figure out what to do with it, show you how to get it up and running. I'm not teaching how to be a certified welder. I'm not one myself. But if you're a hobbyist working in your garage, you need to get started. We're going to walk you through some of the settings, how to verify the settings, what settings do you use, and some technique on how to get started. This will be one in multiple series. So let me show you how to get that new welder up and going. Doesn't matter if you have a Lincoln, a Miller, ESAB, Harbor Freight, whatever the brand. It all comes down to a few basic settings. Let me show you where to get started. So there's a couple different transfer modes when you're talking MIG welding. And we're going to go over short circuit MIG. As the wire comes out of the gun, it makes contact with the workpiece. This is going to melt back to a point. And it's this point that we're going to manage with wire speed and voltage. You don't want it melting back here or too low. With ideal speed and voltage, this will come off and melt and make nice little beads as it goes across. Now on your wire feed, your feed equals heat, right? So your feed will equal the heat of the weld. So if you can't get the wire feed, you can't put the voltage and or amperage into the weld. So that's why it calculates off of wire feed first, and then we'll set the voltage. Now there's a couple things you're going to need to know when you want to set up your machine. You're going to need to know roughly how thick material you're going to be welding. You're going to need to know what size wire you're going to be running. So if we're running 1/8 inch material, and in our Miller we're running 35 thousandths wire, the wire's got 1.6 inches per minute burn off when it's welding. So the calculation comes out that I need roughly 200 inches a minute on the wire feed. And the voltage, well, we'll get to the voltage. And keep in mind, this is all going to change. This is all welding flat. You start welding vertical up, vertical down, or overhead, you have to back some of these numbers off. So let me show you these on the Miller. Alright, on this machine, it'll actually tell you what your wire feed is. But what happens if you just have a 1, 2, 3, ABC, some other switch? If you're trying to get your wire feed set to 200, how do you know that's really what you have? So if on your machine you have a, let's say a 1 through 10, you could set it halfway and see what your actual feed is. Alright, so if you break up a minute into 10 pieces, 6 seconds a piece, what we can do is run the wire for 6 seconds and then see how long it is, multiply that times 10, and that's how many feet per minute you're running. Okay, so this one's got a 2-stage, so it comes out slow, then fast. So I need to see how, pull the trigger, minute it starts feeding, there's 6 seconds worth of wire, and we should be around 20 inches of wire. Alright, so we've got this, so we'll just stretch this out on our tape measure. And since we have to kind of guess where it shifts gears, if you will, I'm about 20.5 inches. So I'm going to call that good. But if your gun just instantly feeds the minute you pull the trigger with no pause, run it for 6 seconds, clip it, measure it. If you take that in inches times 10, that should be what you're feeding at. So if on your dial it's reading, let's say at a 5 it's 200, and at a 10 it's 400, you can very easily interpret where you need to be on your settings. So the Miller, like many of the machines, has a chart on the inside. Now this has a technology that allows you, it'll auto set for you. But if you don't have that feature, you quickly come in here and we're going to MIG with steel wire. And we're using this 35 thousandths rock mount Polaris MIG wire. Now according to this, if I'm going to be running C25 35 thousandths wire, and I'm going to be running 1/8 inch material, 17.7 voltage, 202 at the wire feed. That's for 110. We have it plugged into 240 volt, so we're going to come over here a little farther for 1/8 inch. It says for the 240 volt, which is what we're running, 18.2 on the voltage and 293 on the wire feed. Now get some anti-spatter spray. Wow, that's a tongue twister. And it helps keeping your table clean. Now, especially if you're going to be running flux core, you're definitely going to get a lot of splatter with that, right? So it's just a good way to not getting those big old clunkers everywhere. So try to maintain about a 3/8 gap as you're going across there, right? As you're making your loop, don't push it in so your contact tip hits, and don't get too far away. Try to maintain about a 3/8 gap between the tip here and your workpiece. So we had seen what the panel said. If we go into the smart settings and we're set for C25 gas and we're at 1/8 inch material, 35 thousandths wires, it comes up exactly what it says on the lid. Now from here you can raise or lower the targets. This is what they call their pro settings. Now some of the machines have an auto set like this and some don't. Alright, I think those settings work pretty good. So you definitely want to manage your settings on material thickness. So there's two other conditions. What happens if you're not running enough voltage for your wire feed? So we're going to turn this way down so you can see. So let's go down to like 14. So you see a couple of pop-offs that it did. So let's go to an extreme case of that. Let's take it way down to 12. Alright, so you see what we have there. So just want enough voltage for the amount of feed that you had. So the two work in unison. While we say that the heat is all generated by your wire feed, you still have to have the voltage to support it. So let me show you if you got too much voltage for your feed. So we're going to turn this way up. We're going to go really stupid with this. Remember, if you just have a 1, 2, 3 ABC, you have no idea what you have. So whichever case you have, whether you've got too much voltage for your wire feed or not enough voltage for your wire feed, well, do the calculations, get your wire feed first, slowly either bring up or bring down your voltage. Now, how do you know what size wire you really need? Right? So this is for our rock mount Polaris that we run. So it's calling out, we run 35 thousandths diameter wire. And your voltage range, 15 to 29, we're running about 19. So we're right in the sweet spot of that. And our amperage And if you kind of use your theory of, if you use the theory of for every 1/1000th of thickness, you need 1 amp, 125 amps for a 125 thick material. You know, we're right in this range. Where this size wire wouldn't be any good, if you start talking about sheet metal where you're going to go 1/16 or below or around 1/16, that's going to be a lot of weld you're piling on, you know, really thin sheet metal. Now the chart also breaks down something we haven't talked about yet, and that's gas flow. So when you're welding, you need a shielding gas. We run C25, which is 75% argon, 25% CO. Right? Some people run 100% CO. That's, you know, you have to figure out what you want. Most places it's C25 gas. If you don't have adequate shielding, you're going to get porosity in your weld. Let me show you what that looks like. All right, so here's our gas. Right now we're running, if we pull the trigger, we're running 30 CFH of gas. All right, so that's one of the big advantages of flux core. If you're in an area where there's a lot of wind that can blow your shielding gas away, you don't need shielding gas with flux core. So I barely had any shielding gas on that. And it's kind of hard to see, but there's a lot more oxidation on the outside of it. So let me go way down on the gas, as in turn it off. And that welded like, well, crap. You can see all the extra spatter. Now the shielding gas kept all the oxidation and contamination out. And you can see what that shielding does for you. It keeps the weld in a good environment, and it lets it cool in that environment as well. This you'd have to grind out. Alright, so what I would suggest is get you a piece of material. I would say maybe around a 3/16, something like that. And we're just going to practice technique at this point. Once you got your feed working right so that it's a nice smooth crackle, the next part of this is manipulation of the gun. Right? So I always try to keep the wire, and what I use is the pliers. If I just set them down on the nozzle, it's going to make it, I'm going to call it 3/8 of an inch. So once you cut it, it's going to make it around, well, it's exactly 3/8 of an inch. And that's a good way to start. You don't want to start every run with wire like this and let it pop off, because now that is either in your weld or stuck to it somewhere else. So just turn it over. Good place to start. Also, make sure your nozzle stays clean. If you've been practicing and it's getting a little dirty, that's what this part of the pliers for. Right? Just go in and ream it out. Check to make sure your contact tip is still good. It's not all burnt off. Your gas ports, make sure those are clean. So they make the nozzle gel you can dip into, but if you do that, strike a bead on something. Don't do that and go right into your work, because it fills up your gas ports. But I always give it just a little spray, and I also spray the nozzle. If your settings are right, this doesn't really build up very much. And it's always good to have a piece of scrap laying around, so that before you start actually welding on the job that you're wanting the welds to look good on, grab your piece of scrap and lay some beads down on that first. Alright, since we're welding with hard wire, we're going to take our welding gun. So if it's vertical, drop it back about 15 degrees. and we're going to run. Right? So make sure that you can slide your hand. You don't want to do this. Your gun's way out of position by the time you get out to here. Right? So the biggest part of this is be comfortable. Don't try to one-hand it because your gun's going to be all up and down. Get it in a good position to where you can run either here or here. If you're running very high amperage, if you get this too close, the back of your hand's going to burn very badly. And remember, MIG gloves are always a little thicker. It's almost like the ones you would wear for stick welding. So as I go, I'm going to just make a small loop all the way up. So you'll lay a bead down. Now when you're doing this, the wire, I'm making a small circle every time as I go through. You can run a stringer just as well, but the key to this is make sure that you're running on the leading edge of the pool. It would be hard to show this, but if the melt front of the wire is here, don't be so slow that your wire is back in the back of it. Try to stay right on the leading edge of the wire as you go. So your speed is going to also be the third component of this. Voltage, wire feed, then your feed. Otherwise, you're going to build this big blob up. So on this plate, just slowly go through it and lay bead after bead after bead. And then just keep going across the plate. Right? So go all the way across the plate, then turn it over and go 90 degrees to it. Now what you're looking for is this hump. You don't want it to be too pronounced, which means it's probably run a little cold. And you want to look at the toes of the weld. You don't want those to look like they've just been rolled over on or dug out. Right? So if you're running along fine, what you're watching is you're watching this pool, you're watching it backfill as you come around. So as you go, you're making it loop, you're filling, you're moving, you're filling, you're moving. So let me show you what one looks like if you're running too fast and one running if you're too slow. Alright, so if you're running too fast, it looks something like this. Then next to it, I'm going to put the one in that's running too slow. Now as a little tip, if you can't see what you're welding, you'll never make a good weld. So I actually wear reading glasses in my helmet. Alright, so if you see here, this one where I ran really fast, really is no penetration. Right, just a little worm track of a weld that ran through here. Really didn't get into the plate at all. And this one where I ran real slow one, you can see where it just kind of rolled over the edges. I was back behind the leading edge of the puddle. So the penetration's, I'm sure, not that good either. So just always try to stay right on that leading edge as you walk it down, right? Just loop it, stay right there. Alright, so make sure you go through and you at least check your wire feed. And I'll link that chart that we showed you, how to get to your wire feed and voltage needed. That'll link you to our website where that'll all be there. We'll also have links down there for any of the rock mount products that you see here that we use. Remember, we are an affiliate, so I'd appreciate if you tell them Jeepingmo sent you. But as part of this fabrication series, this is just how to get you started. Get you a plate and just run beads back and forth, turn it, run them back and forth. And we've covered flux core in the past, but as one of the videos in this series, we'll get into more flux core, T-joints, welding tube, and all of that. Right? And if any of the PPE and all that stuff, there's videos on a channel from that as well. I'll add some links in the descriptions. So anything else you want to see, please let me know. This has been the fabrication series. I'll see you in the next video.